Hello, everybody. Good morning, good afternoon, good evening, wherever you are in the world. Welcome to today's webinar as we talk about improving IT resilience and simplifying your migration to AWS. My name is Gonen Stein. I'm the head of product strategy for the CloudEndure service team within AWS. And with me, I have Garrett Pollard. Garrett, did you want to introduce yourself?
Hello, everybody. My name is Garrett Pollard. I am the CloudEndure specialist for disaster recovery here at AWS. And I'll be starting us off here today. So let's get started. We can probably all agree that there are good reasons to move to the cloud. Cloud allows you to pay for what you use when you use it. Although cost savings and efficiency are often the first things that come to mind when you think about moving to the cloud, there are many other important benefits that the cloud offers. Maybe you need to move faster as a business and transform your customers' experiences. Or you want to take advantage of digital transformations and modernize your businesses. Maybe you want to reinvest some of the cost savings you realize from moving to the cloud to drive new innovations and business models. AWS has many services globally, like IoT or AI/ML, to take advantage of, and it all begins with migration. Or maybe you know that the cloud will improve your IT resilience, and we'll cover a bit of that here today. A recent IDC report quantifies some of these benefits, such as productivity boost, reduced infrastructure costs, and less downtime. Starting with lower costs, customers typically save 31% on their infrastructure. Around staff productivity, AWS customers show a 62% improvement in productivity for IT infrastructure staff and a 25% higher developer productivity. When it comes to agility, customers who adopt modern application development practices in the cloud are delivering on average 3 times the number of features. And finally, resiliency. There is 7 times fewer unplanned downtime using AWS. So we just mentioned that the cloud helps with IT resilience, but that doesn't replace disaster recovery. Let's talk about the difference between the two. Resilience focuses on protecting core services and preventing issues before they occur. This can involve identifying the risks and vulnerabilities associated with the services that support critical business processes and performing detailed risk assessments of the impact of an outage. Measures are then taken to remove these risks. Being in the cloud is a strong step towards resilience. The main benefit of increasing IT resilience is to reduce the risk of something bad happening or workload experiencing downtime. Disaster recovery, on the other hand, is the process of getting services back online after a failure or outage. The goal is to get your business back up and running quickly with minimal downtime and data loss. The main benefit of a robust DR strategy is to decrease the time to recover if an event occurs. These disruptions can come from a number of different sources: application errors in databases and web apps, infrastructure access interruptions to compute resources, storage, or networking that runs your applications, or a natural disaster that prevents physical access. Also, human error, like a bad patch that was rolled out or bad code that somebody committed, rogue actors, or even ransomware or other attacks can all be things that disrupt your ability to conduct business as usual. So essentially, DR provides additional protection once you are in the cloud. It increases the resilience of your migrated applications and supports business continuity. Because there is continuous data replication, you can even meet the most stringent RPO and RTO requirements. And as we said earlier, it's the way to get back up and running quickly in the event of a disruption. So to recap, we've covered two main things: the benefit of migrating to the cloud and using DR for additional protection. And often customers think about these two things as two completely separate initiatives. So let's take a look at how you can streamline that process so you get the benefit of quickly getting to the cloud while also putting a DR solution in place to protect your workloads. Basically, it's a single solution to improve your IT resilience while allowing you to familiarize your side with it in the AWS cloud. Lift and shift migration is the fastest way to get to the cloud. For those who aren't familiar with lift and shift, it's actually exactly what it sounds like. Applications are lifted out of their existing environment and shifted, as is, to the AWS cloud. This makes it a fast, cost-effective approach with very minimal disruption, since no changes to applications, business processes, monitoring, or management interfaces are necessary. Once customers are in the cloud, they can start taking advantages of the cost savings, agility, resilience, and all the other benefits of the cloud. And if they use a solution like CloudEndure Disaster Recovery to lift and shift, they can get the added benefit of having a comprehensive disaster recovery solution in a place that will immediately start protecting their workloads. You can also use CloudEndure DR as a mechanism for migration. You would simply deploy CloudEndure DR, fail over into AWS, and repoint the replication to another region for DR. Other customers use this method as a mechanism for migrations at a later date, while beginning to use their CloudEndure Disaster Recovery to protect their on-prem environments with AWS as a failover target. Once they are ready to move the workloads into AWS, they can simply fail over and then repoint that replication to another region for DR.
Okay, thanks for that, Garrett. So this is Gonen again. Let me start getting into the technical components of the solution to help understand why customers enjoy using it and the different benefits and values. So let's talk about the disaster recovery solution at a glance. If we look at the primary pillars and advantages of the solution, we can summarize them under the categories of flexibility, reliability, and a high level of automation. Specifically, the solution operates as an agent that gets installed on the source machines that you want to replicate and protect into the cloud. And this agent is supported on all common flavors of Windows and Linux operating systems, irrespective of their source. So the source could be physical machines, virtual machines running on any hypervisor, other clouds, or within AWS across availability zones or regions. So you can really replicate from any source as long as the operating system version is supported. And as I mentioned before, the operating systems are all the common, they include all the common flavors of Windows and Linux. The replication itself is done at the block level, which means that any applications or databases that run on these operating systems would be supported as well. All the common flavors, as well as off-the-shelf or custom applications, doesn't really matter because replication is done at the block level. Now, the solution allows you to both fail over whenever there is any kind of outage or for test purposes, as well as fail back. So if there is an outage, you fail over into the cloud or over to a different region in the cloud, and then you want to fail back once the outage is over, you can do that using the CloudEndure Disaster Recovery solution. In terms of reliability, so as I mentioned, replication is done at the block level, which means that it is extremely robust. Everything is being replicated, including the operating system, its configuration, system state, any application data and application configuration, databases, files, file systems, and nothing is left behind. So the solution is extremely robust, 100% predictable because nothing can be left behind, and also non-disruptive to the operation of the system. Replication is done in real time and captures any changes live as they happen. Since the replication is done continuously, the recovery point objective, or what's called the RPO, is measured in the seconds range, meaning that you lose only seconds of data in case of an outage, and then you can recover the system using its most recent state. And you can recover very quickly, which is the RTO, the recovery time objective, the time that it takes to recover from the point that you've declared an outage. The solution also allows you not only to recover to the most current point in time that was replicated, down to the seconds range, but also to go back in time. So if there is any kind of situation of a malicious attack, such as ransomware or data corruptions, or just plain human error that forces you to go back to a previous point in time, the solution allows you to have that flexibility as well. And everything is highly automated. So the process itself of getting the agents deployed and replicating different types of operating systems and different types of applications is the same unified process across all different platforms, irrespective of the infrastructure, operating system types, application types. So it requires a minimal skill set in order to operate. And it's very easy to initiate replication, initiate tests, initiate non-disruptive disaster recovery tests, and you can automate these things as well. So everything the solution offers can be highly automated using RESTful APIs that you can initiate at any given point in time. And the infrastructure itself is also fully automated in terms of making sure that only the infrastructure that's required to maintain replication is provisioned at any given point in time. All right, so let's talk about the business outcomes of cloud-based disaster recovery. When you use cloud-based disaster recovery, you can improve your operations significantly, make them much more robust, and ensure that your application workloads are reliable and more highly available, and be able to achieve top-tier recovery objectives, both on the recovery point objective side, as well as on the recovery time objective side. The next piece, the next significant advantage is the operational efficiency. And I think this is something that's extremely critical as you compare cloud-based disaster recovery to traditional on-premises disaster recovery, which in the on-premise world, you really have to pay for duplicate provisioned infrastructure upfront in order to facilitate disaster recovery, meaning that you have your primary facility and then you have a secondary facility, your recovery facility, which requires the same level of provisioning of compute, storage, networking, software like operating systems and applications and databases. And that is very inefficient in comparison to using cloud-based disaster recovery. Cloud-based disaster recovery allows you to only pay for what you use when you actually need it. So there is no wasted infrastructure. During ongoing replication, the solution itself basically replicates the data and uses very minimal compute. So the infrastructure that you're paying for during ongoing replication is comprised of primarily storage and low-cost storage, effective storage. And only when you have an outage and you want to recover, or during a disaster recovery test, you have the ability to launch everything, and at that point, pay for that infrastructure. Until that point, you're primarily paying for low-cost storage and not paying for expensive compute, not paying for networking, not paying for software licenses like the target operating systems or the target applications or databases, and it makes a very operationally efficient disaster recovery solution. And finally, there's the resilience peace of mind. When you have cloud-based disaster recovery solution deployed, it's very easy to conduct tests very frequently and in a less disruptive fashion in comparison to on-premises disaster recovery tests, which force you to use the same target infrastructure. With cloud-based disaster recovery, the test itself is not something that impacts the source environment. It doesn't impact replication in any way. So during the non-disruptive test, replication continues and your recovery point objective is not impacted. Okay, so now that we've talked about the business outcomes, let's talk about the life cycle of using CloudEndure Disaster Recovery on AWS. With any disaster recovery deployment, everything starts, the lifecycle starts with assessing your source environment and mapping out what it is that you want to protect, what servers comprise your different application workloads, what is the interdependencies between different servers that comprise an application, their networking, right-sizing their instances, and so on. And then defining your recovery objectives, your recovery tiers, based on the criticality level of your different applications. Once you have that sorted, you can start the process of setting up your cloud-based disaster recovery environment, which is comprised of installing agents. You install the CloudEndure Disaster Recovery agents on the source machines. These agents are deployed in a non-disruptive fashion, so there is no reboot required on those servers, and the performance is not impacted in any noticeable way. Once the agents get deployed, the replication itself begins, what's called the initial sync, in which the baseline of the data is being read from those source servers and being replicated into a dormant, what's called a staging area in AWS, into that lightweight staging area in AWS using low-cost storage. And during that replication time, you can already start to configure the next step, which is called the blueprint. The blueprint is what allows you to define where and how each of the servers are going to be launched and recovered in the case of an outage or a test, meaning that you can define the target networking, the subnets, security groups, and other properties, instance types, storage types, and all kinds of related properties that dictate the behavior of the target server whenever it's being launched in AWS, again, during either an outage or a DR test. And when the initial replication is complete, it turns into what's called CDP, continuous data protection. From that point, once the initial sync is complete, replication captures anything that changes on the source machine in real time. So any files that change, any blocks that change, any configuration, really anything that's written to the source volumes is being captured in real time. And so you can conduct tests or actual recovery events at any given point, and you can recover either to the most current point in time or a previous point in time, as we mentioned before. So that's the setup. When we complete the setup and deem our servers as recoverable after we've successfully tested them, we turn into what's called the operation stage, which is the ongoing stage. During that ongoing stage, replication is going to be maintained in real time, capturing any changes in real time, and periodically you can test that everything is working as expected. So as things inevitably change in your source environment, whether machines move from one network to another or additional machines get added to your workloads, you will need to maintain that, install agents on new servers that get added, or change networking properties based on the changes in your source environment, and continuously test and ensure that your applications are functioning properly during the recovery test. That's what you do during operation. The CloudEndure Disaster Recovery console also allows you to see at any given point what the replication status is. So if there's any kind of lag because of networking issues or other issues, you will see those things in the console, and you can report on those types of issues automatically and trigger alerts. And then if and when a recovery event is needed, meaning that you have an outage and you actually want to recover, you can get into the final stage on the right-hand side of the screen, which is the recovery that allows you to bring up the machines using their most up-to-date state or previous state, get those servers up and running within minutes, redirect the users so that they can continue to run their applications in the cloud, in the target cloud location. So redirect the user traffic to use the cloud-based recover machines. And whenever the outage is over and you can go back to the original environment, the solution allows you to fail back. Failing back consists of reversing the replication direction from the recovered machines that are now running in the target cloud environment, reversing the replication back into the source, whether it's to a different region in AWS or a different source altogether, like on-premises. And once the replication is reversed and is complete, you can redirect the user traffic back to the original environment, complete your failback, and reverse replication once again in order to get back to square one of replicating from the original source environment into the cloud in order to protect from a subsequent outage. So let's move on to discussing the architecture of how the solution actually operates behind the scenes. So as we've mentioned before, the solution itself mainly replicates continuously any of the data that comprises applications and databases and operating systems from source environments into AWS or within AWS. And from an architectural standpoint, on the left-hand side, we can see a representation of a source environment, which could be a corporate data center or a cloud, either AWS or another cloud. And in that source environment, we see a sample of two servers. One hosts an Oracle database, another one hosts a SQL server. And those servers have a total of 5 volumes attached, 3 volumes to the top server and 2 other volumes to the bottom server. And those 2 servers are installed with the CloudEndure agent. Again, non-disruptive, no reboot required, just roll out the agent. You can deploy it either manually or in an automated fashion using any kind of deployment tool, software deployment tool. Once the agent is deployed, it establishes connectivity with the CloudEndure console that you can see on the top part of the diagram. This is for authentication purposes. So the agents basically communicate and say, hey, we belong to customer account A or B, and we have such and such volumes attached with such and such sizes that we want to start replicating. The CloudEndure console communicates using AWS APIs with the target account of your choice and automatically provisions a staging area. So in the center of the screen, in the diagram below, you can see that staging area, which is basically that lightweight environment that is used solely for replicating the data. This is a non-functional environment in terms of your applications. Nothing is really running there in a way that you can use. It's just there to keep the data in real-time sync. So once the agents get deployed and communicate with the console establishes that staging area resources, including very lightweight compute resources. You can see those compute resources as lightweight Linux EC2 instances that are used to keep the data in sync. So once those instances are launched, the connection is established between the agent, the source agent, and those staging area replication servers. The staging area replication servers are attached to volumes, low-cost EBS volumes, Elastic Block Store. And those volumes are being used to keep the data in sync into that storage, staging area storage. So each block storage volume, EBS volume in the center of the screen in the staging area represents the identical size of the volumes that you see from the left-hand side, from the source environment. And that is what's used to maintain the replication for the initial sync as well as continuous sync. And during ongoing operation, the only resources that are going to be created and maintained are the resources in the center of the diagram, the staging area. The target environment on the right is not going to be created until you are ready for a test or for an actual DR event. But once you do have an actual recovery event or you want to test, then you can use the console to trigger, using the user interface or APIs, you can use the console to trigger a test or trigger a recovery event, at which point what happens is that the console sends a different set of APIs to the AWS account of your choice. And those APIs will then take the volumes that are being replicated in real time within the staging area in the center of the screen and clone them to the right-hand side. So within seconds, those volumes are going to be cloned into the target subnet that you've defined in advance in your blueprint. Those volumes are going to be attached to the actual instances that need to run those workloads moving forward using the right-sized instances. So the ones needed to run the Oracle database from a compute and memory perspective and the SQL server. And that is also the point where any of the boot volumes that originated from outside of AWS, like a boot volume that was replicated from a VMware environment or from a physical machine or from other clouds that are not initially compatible running in AWS, that is the point where the CloudEndure Disaster Recovery service also performs what's called a machine conversion that makes those volumes Amazon native, meaning that irrespective of where they came from, physical, virtual, any hypervisors or any clouds, those volumes will immediately become launchable, bootable, and work just fine within Amazon EC2. So to summarize the platforms and applications and operating systems that are supported, so everything starts from the operating systems themselves. So all the common flavors of Windows, starting from 2003 server and above, and the common flavors of Linux servers like Red Hat or CentOS or Oracle Linux Ubuntu and so on, those are supported with all the common versions as well. And as long as you're running a supported operating system that is supported by the CloudEndure Disaster Recovery Service and the Amazon platform, the AWS platform, the rest is transparent. So the source infrastructure will be transparent, whether it's a physical data center or different hypervisors or other clouds or within AWS. And of course, anything running on top of the operating systems would also be supported transparently because of the fact that replication is done at the block level. So common databases that are used across the environment would be SQL servers, Oracle databases, SAP types of workloads, and MySQL servers. But really, there is no limit to the types of applications, either off the shelf or custom, that can be supported, or databases. Here, you can just see the common ones that our customers are using with the solution. Okay, so now that we have a good understanding of what CloudEndure is, how it works from a technical perspective, the architecture, and the platforms that are supported, let me hand this back to Garrett to talk about some of our customer case studies. Garrett, back to you.
I'm going to share a case study about Malibu Boats as an example of the features and benefits we have covered so far today. Malibu Boats is the world's largest manufacturer of high-performance sport boats. They use CloudEndure DR in order to achieve rapid recovery while meeting budgetary requirements, ensure their disaster recovery target is geographically distant from their primary data center, expand their disaster recovery strategy to keep up with growing business and IT environment, have the ability to fail over to a previous point in time in case of the server corruptions or cyber attacks, have the ability to fail back to a primary data center without disruption or data loss, and plan for the long-term migration of production servers in the cloud. In other words, they recognize DR as a safe way to test the migration waters, so to speak. As luck would have it, shortly after implementing CloudEndure DR, they had a disruption. They experienced a server outage that was running mission-critical applications. Because of that outage, Malibu Boats realized a few things. CloudEndure DR enabled failover to AWS in minutes, so they didn't have to shut their factory down. They were able to roll back to a previous point in time prior to the server corruption. And while running in AWS in recovery mode, their server had 2 times faster performance with the same machine specs. This was an unexpected benefit that actually led to a business decision to significantly expedite the migration to AWS. They had tested the process and gotten comfortable through the initial migration, and then real-life failover and failed back, so they knew the cloud was certainly the way to go. CloudEndure Disaster Recovery is sold on the AWS marketplace with flexible, usage-based billing, allowing you to easily use the solution by paying an hourly basis instead of committing to a long-term contract or set number of servers. Purchase via self-service through the AWS marketplace, or you can turn to the AWS professional services, account team, or your consulting partner for assistance. To learn more about CloudEndure Disaster Recovery, visit the product page at aws.amazon.com/CloudEndure-disaster-recovery. Thank you for your time today. It was a pleasure, and look forward to speaking more about CloudEndure with you guys in the future.